So we've looked at this MITS 88 SIOB card in a couple of previous videos. This is an RS-232 TTL level card, and I really want to convert this to be EIA levels. And I've looked at a couple of different ways to do this, and I think I'm going to go ahead and just use a 1488 and a 1489. These are RS-232 line driver receivers. The date codes on this one is 82 and 83, so they're a little bit later than the board, but still pretty vintage. I've got minus 12 volt regulation on the board. I'm going to have to add plus 12 volt regulation. And the only real regulators I have floating around are this, and it's an interesting label, 78012 AP. I may need to look for another 7812. I'm not totally confident. But what we had here was a 1897 or 74LS367 driver IC sitting in this socket right here. And data in and data out from the UART come to this chip, kind of as I've somewhat drawn here, come to this chip, and data out comes and goes through one buffer and out to the edge connector pins up here, and then data in comes in through one buffer and back to the processor. So the socket that chip in is really a natural place to translate the signals. We'll have TTL on one side and the EIA levels on the other. So looking at ways to do this, I decided maybe a piece of proto board would work well. I can get that screw hole pretty well lined up, where I think I can get a screw with a spacer through there to kind of give some mechanical strength. You know, it's not as perfect as I'd like. Alignment, that's not any better. You could go up a pin. That's probably about as close as I'm going to get it. And the idea being this will be an add-on board that'll plug down into where the 1897 was. And then there'll be a 1488 and 1489 on this board to do the level translation and the voltage regulator to get me the plus 12 volts I need. And so from kind of this, I went ahead and drew up this little wiring diagram here, where the socket is here in the middle, and I'll put the 1488 down here, the 1489 up here, and the regulator on the side, and just kind of use it as a plug-in board. There'll have to be two wires that come off this. One of them will connect to minus 12, and one will come over to where the minus 15 comes in to the machine to local voltage regulation. So let's tack a couple of pins here. I'll just tack one for now. And the piece of proto board I'm using here is also from kind of back in the era. I think it had a date code of 84 on it. So again, you know, pretty nice. And this will really just get point-to-point wired. So what that should give me at this point is a little board that plugs down into the IC socket. And gives me a way to connect and do the level translation. So that somewhat seems to work. So let's add a little more solder on some of these pins. Just to kind of get that mounted down. And this socket also brings plus 5 and ground up onto the add-on proto board. And of course we're going to need ground reference for both the 88 and 89, and we'll need the plus 5 to power the 1489. So, you know, that's already pretty solid. I wish that screw hole lined up better. It'll torque the board a little bit, but I think it'll be usable. And the idea is the 1489 is going to sit up here someplace above it. 1488. This is drawn here. We'll sit down below it. And the voltage regulator will just get mounted over here. I'll have to drill a hole. Well, potentially drill a hole. I don't know if I'll actually need to. The leads would actually be enough to hold it in place. I'm going to go grab the box of voltage regulators. So hold on tight and get one that I recognize the markings on as soon as I spot them. Voltage regulators. Voltage regulators. Actually got some old Tandy 12-volt regulators in here as well. Might be kind of fun to use one of these. It's certainly old school. At some point I picked up a bunch of surplus electronics, and there was a bunch of these Tandy voltage regulators, which was pretty sweet to find, and that's actually got a really broken up Mylar washer with it. Well, I am going to assume that is a 12-volt regulator. If it was to be mounted right there, the pins would get bent. Let me drill a screw hole here. Someplace in there will be just fine. Let's just get a hole here so we can actually put a bolt in it, do it right, give it some mechanical strength. Gives me a hole through the board. And all this old dead fiberglass can go into the trash. Bend those right at the knee. Figure out what set of holes they need to go into. And it will mount on there like that. That's pretty nice. It's going to be a nice looking little board. It'll have, of course, the pins to hold it in, and there'll be a little retaining bolt up here, just to give it more mechanical strength. So pretty cool. The 1488 is down low. I had it on there a minute ago. Get some solder on that voltage regulator. And hopefully it's a good regulator. Just to hold it in place. hold that down flush. And I'm just going to use point-to-point wire for this. We will tack one pin. And it's definitely not in square or straight. Let me hit the other corner. Doggone it, I touched one of the pins on the little pin header there and got a bit of solder on it. And the 1489, that's not it. The 1489 goes up here. Couple of corner pins. Now the roll of tape is always someplace where it's a pain, where it keeps sticking to me. And we will tack down all these pins. And of course, I'm making a lot of assumptions here that the 1488 and 1489 are good. They were pulls. I don't really want to socket these. It's already going to be a fairly thick sandwich with these two boards like this. I need to have room to clear the board in front of it. Bend these pins down. I haven't decided yet. So I should solder them first. And I'm just going to go ahead and trim them after thinking about it. Look like I have a solder bridge. Well, that's pretty nice. I've really got 3 ground connections to make. The 3 devices coming off of here. I guess it's really a question of how best to do that. And there's several ideas that come to mind here. How heavy is this wire? I would like the ground to have a bit of heft to it. course, the center pin on the regulator is ground. And that's going to come over to pin. How to do this? Maybe I'll do it like so, and just run it up the board. Now the question becomes, can I get two of these wrapped together to actually fit through the hole here? And I can. Now if I got a bit of solder to those. Of course, with the solder on them, they're a little too thick. Of course. Go, that went through. Bend that over to the ground pin. It's going to jump her up to ground there and up to there. Oops. It would help if I actually wrap those about with the insulation at about the same point. Tin that up. How am I going to do this? Now this is what happens when you do things on the fly. Oh, shoot. Try that again. I'm having no luck with this. Easier if the board wasn't flopping around. That picks up ground. It's going to loop up to this device. Is a ground right there. Not a big fan of those wires hanging off like that, but it is what it is. That'll go in like that. I need to bring 5 volts to the upper device here. I'm soldering it to one of the extra pads along with to the pin and the pin header, just for a little bit of extra mechanical strength up here on top. Now it's going to come around to the VCC pin. Like so. That should bring power up to the 1489 up here on the top. I need a wire coming off the board to pick up -12. And a second wire coming off the board to pick up +15. +15 is a bit of a long run. It's coming from down here. I don't have a great place to pick it up. That's the other problem. There's no plated through holes or anything where the +15 would be here, which means I'm just going to have to tack this in place as best I can. Would have been nice had there been like a plate through or something off of there, but there just isn't. So this is the one thing I don't like about how I'm doing this. So I don't want to get solder down onto the gold. Will get routed. Kind of up along and onto the board. I'm not going to mount that up yet. Bit of a kludge. The +12 can come directly onto the board. Prefer to not use red, although honestly red will be fine. Really, there's just 4 more wires to add on the board here, and the little board will be completed. Actually 5 more, but before I hook up the +12, I really want to power the board up and make sure it works. Which means I probably really do need to bring this through and get it soldered on. And just make sure we're getting 5-volt regulation. Tempted to kind of route this underneath a couple of these capacitors. Just to kind of keep it down on the board. It's going to drop down through there. Come over to the input on this regulator. This would be easier to do if I had better glasses on. Oops. The wire's now attached. I got to be a little careful here. I don't want to break it. That should be enough to get me +12 out of the output pin on that regulator, and the next step before I go any further is to make sure that regulator is actually working before I put more jumpers on. So I'll go down, pop this in the machine, measure the voltage quick, and come back and we'll finish the wiring. Okay, I'm back. We have enlarged the hole here slightly so it lines up better, and I've verified that there's 12 volts on this regulator, and there is. So really it's just a matter now of finishing up little bits and pieces of wire in here. So let me tin this guy up. Let's see, minus 12 comes in down here. And of course, now that I have leads here, it makes this a little bit tougher. Minus 12 is going to come to this minus 12 volt tap up here, which I have already, I just off camera solder vacked out the hole. Pick up minus 12. Luckily there's minus 12 volt regulation on the board for the UART chip uses minus 12, and I need to jump for plus 12 on the 1488 to the regulator. Then really it's just the 4 signal wires. It's going to jump her from there really to there. Oops, that's not the solder. Should be coming through right there, and it is. And that should get all the power supply stuff hooked up. Now I need 2 pieces of wire. They're going to go from 2 pins here to 2 pins there. I don't know if this bell wire will even take solder. but I can't strip it. Doesn't look like I nicked it. I just don't like the way that wire's forming. We'll just go ahead and use more of the ribbon cable here. Better if it was twisted. Oh, that tip is dirty after touching that bell wire. From a little solder ball on the end, won't fit through the hole. It's going to really run from a very short run here to there. Tacked on the top of the board here to that pin there, and then it feeds through to pin 3. Find the better glasses. To pin 3, and there's going to be another one. Get that kind of bend up out of the way there. With the brown wire, it's going to go to pin 1. That's not the brown wire I prepped, I don't think. It is, but it looked pretty nasty, so I'm going to do another one. That's going to jump her over to there. Actually, let's get it back in the socket. Keep it from sliding around. Yeah, so far. And we're going to go to the 1489. It's a very similar thing. Strip the wire back, tin it. It's really short. It's going to go from the second pin really to there. It's a pretty short jump. Way too long. What are they barking at? Sorry, I'm doing a lot of this off camera. That'll get soldered to pin 1. We have this final wire, which actually comes over and connects to 2 pins on the driver. Which is going to be every bit as short. What are you barking at, McStinker? Yeah, sorry, I've got a lot of this happening off camera. And it is going to jumper to over here. And it comes up through the back of the board and actually goes to 2 pins. 2 pins. Got a nice solder bridge with the wire down the middle. So let's just double check the wiring. We've got the socket to those 2 pins, the output back up to there, ground to ground to ground to ground, plus 12 to the regulator. We'll have to pick up minus 15, minus 12 coming across there, plus 5 coming off here, plus 5 on him, to there and to there. That all looks correct. So really now it's just a matter of figuring out some hardware here to help hold things in place. Now, of course, requires the big tub of hardware. See what I can find here. So much hardware. I'm going to get a short screw, a nut for that voltage regulator. So it is mechanically connected. Of course, can't get my big old fingers in here. Wish these were sorted better. It's always kind of trial and error. Those do made up. Drop you down through there. Get some pressure on it. That's way too big a Phillips, of course. Well, the screwdriver I need, as always, isn't just laying here. That is really weird. Well, this will work. Get some tension on that. Let's take a look at the height there for a spacer. I hope that I have something here that'll work. That's going to be too tall. That's obviously too short. That's actually a pretty good length. The question is, can I find 2 very short screws that'll work with it? It's a good length, except that shaft is too long. Keep digging here, see what I can find. there's a couple of choices there. I don't know if I need these screws. Will work with these spacers. I don't think they do. Actually, that does. They got one that'll screw in from the top. Well, what do you think? Looks like a bought one. That's down in the socket really nice. That's got some nice mechanical relief there. Pretty slick. I'm pretty happy with that. That turned out reasonably well. Of course, the real question becomes, will it work? And that'll have to be tested, but that should be giving me now EIA levels on the two pins here on the connector, and then I can just bring these out to a DB25, and we should have, you know, EIA level RS-232 on the board, which will be nice. Part of me wants to hot snot those down. Which means the old ASCII televideo terminal I've got will work with this, and that's the goal. The idea is to make this into the TTY0 device on the computer, but before I restrap it, I'm going to test. And to test it, we put it back in the computer, we jump her in and out together, and we exercise it in a little basic program and see how it goes. That seems to be in there well enough. It's not quite flush, which I don't like. Let me add a spacer or a washer. Look for an appropriate washer here. Spacer's a little bit short looking at it. Pull the board off. I'm actually going to put the spacer under the standoff and hope that the screw length is still long enough that some threads will catch. We'll try that. Yeah, that's definitely better. Yeah, the board's pretty much flush to the other board. Pretty close. So hopefully that makes some sense. We've taken the input and output to RS-232 level converters, take them back to TTL, directly through the socket where the 367 originally was on the board, back to the UART. We're picking up +5 from the socket here to power the 1489. The grounds are hooked together. We've got -12 coming directly into the regulator here. We've got the -15 or 16 coming into a 7812 with 12-volt regulation out up here. And that produces really the line driver. Pretty happy with that. That is exactly what I wanted to get. So doesn't look too awful bad. And it's definitely got that homebrew era look to it. But there's nothing wrong with that. That's kind of what we're going for. So with that, I will see you most likely in a future video while we test.